7C, confidence intervals for proportions. So now instead of looking at the mean, we're going to look at percentages. Okay, steps are very similar to before. We're using the calculator. We are back to the Z, but then when we get there, instead of choosing one sample, we're going to choose one P for one proportion. C level is still confidence level, just like before. X, and it's still sample size. X is the number of successes. So sometimes the problem will tell you 14 out of 37 people. Sometimes it'll give you a percent. So, 17% of 247 people. When that happens, you got to multiply N, the total, times the percentage as a decimal to get the actual number of people, because the calculator needs a number, not a percent. So we'll look at an example. We have a survey of 989 adults. 64% said it is acceptable to check personal email at work, and we're going to do a 95% confidence interval. So our C level is 0.95. Okay. For N, they don't tell us a number, they tell us a percent. So I'm going to do 0.64 times 989, so that I get what 64% of 989 is. I'm going to show you in just a second. You can do that right in the Z interval part of the calculator. And then N is our sample size, so we surveyed 989 people. So let's grab our calculator. All right, so just like before, we're in menu and stat. Okay, we want interval still, so F4, Z. And then when here we've been picking one sample, now we're going to pick one proportion. Okay, so my confidence level is 0.95. Whoops, sorry. My X, so I'm going to go ahead and type that math right in there. So 0.64 times 989. And then N is 989. Now, notice we got a decimal number for X because 64% of 989 is not an exact whole number. If you try and do this, the calculator will tell you error. Okay, it needs a whole number for the number of successes. So we're just going to go ahead and round that number if we get a decimal. So 632.96 is going to become 633. And then it gives me my sides of my interval just like before. So 0.61. or 61% to, and this I would round to 0.67. Okay, so 0.61 to 0.67, that is my 95% confidence interval. All right. And then of course we have our application question. So we did an updated survey in 2021 and we had 762 of 1,114 participants that said it was unacceptable. Is this evidence the proportion has changed from 2015 to 2021? And as always with these, I'm going to ask you why or why not. All right, we got to have an explanation for why. We can't just guess. All right, so if we find this percentage, 762 over 1114 is 0.68 or 68%. Okay, we got 64% as our original one in 2015. So that looks like a big jump. And then we look at our interval and 0.68 is outside of our confidence interval. So yes, we do have evidence that the proportion has changed because our sample is completely outside of the confidence interval. All right, the other thing that we can do with proportions is finding a sample size, just like we did with means. So here is the formula. All right, P for P hat and Q hat. P is going to be the proportion. Sometimes we don't know, and so anytime they don't give you a percentage, we're just going to use 0.5. All right, if we do know, if we're given what's called a preliminary estimate, that's what we put in for P. And then just like last unit, Q is always the opposite of P. All right, so if P was 0.25, then Q would be 0.75 because they always have to add up to 1 or 100%. All right, Z sub C is the Z-score that goes with the confidence level. So this is the same as when we did for the mean. For this class, we'll only use these three numbers. All right, and then E is the margin of error that is given to you in the problem. So let's look at an example. We work for a political campaign and want to estimate with 95% confidence. All right, so that means our Z sub C is going to be 1.96. the population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3%. So that right there tells me that E is going to be 0.03 because we're going to take that percent and write it as a decimal. Okay, so find the minimum sample size with no preliminary estimate. So that means for P and Q, we're going to use 0.5. So it would be 0.5 times 0.5 times my Z sub C, which is 1.96, divided by my margin of error. And then this is squared. And we are just going to put that in the calculator. And if you notice, I typed it exactly like I wrote it here with the parentheses, and we got 1067.11. Just like with our sample sizes before, we can't sample 0.11 people. So we are always going to round these numbers, and we're always going to round up. All right, I can't round down because 1067 is not enough. So I need to sample 1068 people. Okay, now let's pretend that we have a preliminary estimate. We have a previous poll or something where 31% said they would vote for our candidate. So if we want to check again, what would our sample size be? Okay, so this time P is 0.31 and that makes Q 0.69 because these two numbers have to add up to 1. All right, and then what's in the parentheses, my Z sub C and my margin of error is not going to change. All right, so let's go put that in our calculator. So we would have 0.31 times 0.69 parentheses 1.96 over 0.03. Close the parentheses and square it. All right, 913.02. And again, any sort of decimal means round up. So that means I'm going to sample 914 people to get a 95% confidence interval within 3%. Okay, and that's it for 7C.